Hello friends, welcome to Financial Analytics. Today's session in R is about data structures in R, and this session is focused on vector in R. So in R, there are four key data structures, and the first basic data structure is a vector that we are going to study today. Apart from vector, we have a matrix to learn, data frame to learn, and the last is a list. So vector is a very simple and basic level data structure in R. Vector play a very significant role in R programming. So let us understand how we can use vector in finance domain, how we can use the best of a vector when we are using R for a financial analytics. So let's start to understand by understanding what is a vector. So let's go to whiteboard and let's start what is a vector today. Let's understand how do we create a vector and what are the types of vector in R. So let us start with understanding how we can create a vector. So vector is created with the C function. So write down a small c, open parenthesis and close parenthesis. And in this way, we can create a vector. So what exactly is a vector? Vector is a sequence of data element. So sequence can be a numeric numbers. So 5, 15, 20, 25, 30. Now, this is a sequence of a data element which is a comma separated. So every number is a comma separated. So 5 and 50 are comma separated. So how we create a vector? We create a vector with the C function. So this is a C function. With the help of this C function, we create a vector. So how we can create a vector with this 5, 15, 20, 25, 30? So we write down here C and open the parenthesis and closing the parenthesis, we can create a vector. And what is this type of this vector? This is a numeric vector. So this is a numeric vector. So if we write down A, B, C, so these are the characters. So if we write down here C, open parenthesis, close parenthesis, this become a character vector. So this is become a character vector. We can also create a vector for a true and false. That is called a Boolean vector or a logical vector. So open the parenthesis and close the parenthesis and write down before the C, it create a vector and write down true and false. So this become a logical vector. Logical vector. And then there is one another type when we have very pure numbers, for example -1, 0, 1 and 2. So these are the pure numbers where there are no decimal points. So these are called integers. And these are called integer vectors. So write down here C, open the parenthesis and close the parenthesis, it create an integer vector. But in R, if we want to create an integer vector, what is an integer vector? When the number is very pure, where there are no decimal points, and if the number is a pure, it can be a minus, it can be a 0, it can be positive number, but there are no decimal points attached to it. So these are called the integer numbers. So how we can create an integer in R? We write a number which has no decimal points and we write L after that number, 1L, minus 1L, 0L, 1L, and 2L. So writing L after the pure number is called integer vector. So these are the vectors. So the types of vectors are numeric vectors, character vectors, logical vectors, integer vectors. So in nutshell, they are called atomic vectors. So atomic vectors contains numeric vectors, character vectors, and logical vector. So all these vectors are called atomic vector. So in last, what is a vector? Vector is a sequence of a data element which are of the same type. So you can see here in numeric vector, there are only numbers. In character vectors, there are only characters. In logical vectors, you can find only true and false. In integer, you can find a pure numbers, whether it is a -1 or it is a +1, but it has no decimal points. So in this way, the vectors are created. And what is a vector? Vector is a sequence of data element which are of the same data type. And what this C function does, this C functions combine the comma separated data elements together. So this is a theory behind a vector. Then there is one another point which is remaining. Always remember that vectors are called 1D data structure. Why it is called 1D data structure? 1D means one dimension data structure. Vector is a one dimension data structure because it has only length. You can see here, it has only length, here only length, only length. In vector, there is only length to the data and there are no height attached to it. So it is not a row and column data structure. And that's why it is called one dimension data structure. So this is the underlying theory behind the vector. So let's go and try to understand the vector in a finance domain, how we can apply it, and we will understand with the finance examples. So let's go to the R Studio. So let us start to creating a vector in R. So what we have learned, we can create a vector with the C function, open the parenthesis and close the parenthesis and put a data inside it, 2, 4, 6, 8. Now what this C function does, this C functions combines the comma separated data elements. Now these are the basically a numerical data, or this is a numbers, and so this vector is a numerical vector. And what this C function does, this C function combines this comma separate data elements. Now what I will do, I am assigning this data with the assignment operator to variable A, and now this entire data is contained in a vector A or variable A. So now this variable A has a data points 2, 4, 6, 8, and now this is a numerical vector which is ready to use for statistical analysis. So let's move ahead by creating a data which is related to finance. Now this is a share price data of JM Finance. JM Finance is a BSE listed companies. Now when we create a vector, because we have two options for statistical analysis of a 7 days share price data. Either we create a Excel file and then we save it, store it, and then import it into the R and go for and then we will go for statistical analysis. But this data is very limited. This is only a 7 days trading data. So rather than to create Excel file and then store it and then importing into R, we simply create a vector because this is a very short data or very small data. So that's why we have created a vector. So always remember, when we have a very limited amount of data, rather than to create Excel file, we have to use a vector in R. So what kind of a statistical analysis we can do? We can do a left, we can find out the length, then the range, minimum number, maximum number, and then in the last we can find out the descriptive statistics of this data, and then we can also plot this data. So let's start by doing the statistical analysis on this data. So this is a JMFIN, and JMFIN is a share price data of 7 days. And so write down JMFIN to see the data inside it. So JMFIN include these 7 days trading data. So move ahead. We will start with the length function. So this is a length function, and find out the length of a GMFIN data. And this, so this is returning a number 7 to us. So what this length function return us, length function gives us shows us the number of data elements in that vector. So in this vector GMFIN, there are 7 data elements, or there are 7 individual numbers. So this is about the length function. Then we can find out the range in the data. A range, give me a range of a GMFIN, and the range is a 68 rupees. So this is a range. What basically range gives? Range gives us 2 numbers. One is the minimum number and other is a maximum number in that vector. And our vector is basically a share price data. So 68 rupees is a minimum share price in last 7 trading sessions, and maximum share price is a 676. So our data is in the range of 68 at a minimum end, and maximum end is a 76. So let's move ahead. By after discussing a range, we can also compute a min. So min of a GMFIN. So min function provides us or return us a minimum number in that vector. So 78 is the minimum share price data. Similarly to the main, we can also find a max JMFIN. So the maximum share price data is a 76. Then apart from length, range, min, max, we can also find out the average or minimum share price data. The minimum or average share price of a JM Finance is 70 rupees and 28 paise. So this is a average price in last 7 trading sessions. Similarly to the min, we can also find out a median, and median of a GMFIN is a 69 rupees. What is this median tells us? This median tells us if we arrange the data in the increasing orders, and then we break that data into 2 halves, then the 69 is the most middle point. So median of a GMFIN data or GMFIN vector is a 69 rupees. So we are in, when we see a share price data, what we are much more interested, we are more interested in learning how the data is stable, whether it is a volatile or not. And the measure of volatility is a standard deviation. So standard deviation of GMFIN is a 2.81. Now standard deviation is basically a statistical measure of a market volatility. If the prices are volatile, they are going up and they are going down, and that is an indication that the standard deviation is high. If the share prices are trading in a range, then the standard deviation is low. So high standard deviation is an indication of a high volatility. Low standard deviation is an indication of a low volatility. So in our case, the volatility of GMFIN share price is a 2.81. So similar to the standard deviation, we can compute the variance of this data, and variance of GMFIN data is a 7.90. Now what is this variance? Variance is basically a square of a standard deviation. So standard deviation and measure standard deviation and VAR we have completed, which is an indication of a market volatility. Apart from these statistical measures, we can also create a plot on these vectors. So simply write a plot. So if so R is a very convenient to use. If you want to plot, just write down the plot. Give me a plot of GMFIN data or GIMP vector, you can see a GIMP vector. If you want to color it into the red, just write down here color and show me in the red. And then now all these points are becoming a red. Now on y-axis we have a GMFIN share price data. On x-axis we have a number of trading days. So this is the first trading day on which the share price is 71. On second day we have the share price of 68. On third day we have a share price of 69. And now we can visualize where is the maximum share price. The maximum share price is here. The maximum share price is 76 on the last trading days, that is a 7. So on last trading day we have a share price of 76. So we can also create a plot on the vector. Apart from this plot, we can also create a histogram of a GMFIN and so histogram of GMFIN, and my histogram is ready. If I want to give them a color, I will simply write color, give me in a rainbow format, and there are 3 histograms, so give me 3 colors in the rainbow. And now our histogram is ready, and we can visualize it that the most of the data points are between 68 and 70. There is only one data point which is above near 76, so that's why we have this histogram. So most of the data points are between 68 and 70 rupees. So in this way we can interpret this histogram. Apart from this histogram and various statistical measures, we can also compute a summary or descriptive statistics of a GMFIN, and this will give me the minimum number in the data, that is 68 rupees share price. The first quartile in the data is a 68.50. This suggests that the first quartile means 25% of the data. The 25% of the data is below 68 rupees and 50 paise. The median is basically our second quartile, and that suggests that the 50% of the data is below 69 rupees. The average share price is a 70 rupees and 29 paise. Third quartile is basically 75% of the quartile. So third quartile indicates that the 75% of the data is below 71 rupees, and the max share price is a 76 rupees. Now there is only one function remaining, that is a sorting. So now if you want to sort the data, sort the GM finance, and now you can, with the help of a sort function, we can arrange our data in the increasing order. Now if we want to arrange this data in the decreasing order, simply write sort GMFIN, give me the data in a decreasing order, and my decreasing order is a true. And now you can see here our data in decreasing order is ready. So in this way we have used various functions on a vector, and we avoid to create Excel file. So you can create a vector, you can do a statistical analysis and report it for your use. So this is about GMFIN. Now let's move ahead with another data. At this point, what we have discussed is how to create a vector, how to do statistical analysis on the vector, and then how to make a plot with the help of a vector. And now we are moving towards how to create this type of a plot, because in finance we are interested in creating this type of plots because our data is of this type. Our data include profit and loss statements where companies are profit making, where the companies are loss making. The companies which are profit making, we are interested to show in green. The companies which are loss making, we are interested to show in red. So let's try to focus on the various parameters in this plot. So the first parameter in this plot is this P and L. This is a title. And in R, if we want to create a title, then we have to use a main function. So when we write main is equal to P and L, it becomes a title. And then we can see here the y-axis, and the title to the y-axis is a profit and loss. To write a profit and loss on y-axis, we have to use the function ylab. Then you can see here the y-axis is in the range of -20 to 60, and this range is given with the help of a ylim. And we have to be very careful when we are assigning the limits to this axis, because if we increase the limit to the limit of this axis, then these bars become a very small. So you have to be very careful. So my maximum height of the bar is a 65, so that's why I have write here a 60. It is, if I write 80 or 70, it in even that is a better one. In the loss making companies, the maximum loss making company is HCL, which has a -25 of loss. So I am here writing a -20. -30 is also sufficient, -40 is also sufficient. But the what is this y-axis? This y-axis in the R is written as a ylim. Ylim means limits. So this y-axis limits is written as a ylim. These are the bar names. In R, if we want to use R names, we have to use the function called names.arg. So names.arg is basically used for bar names. So this, and this is a ab line. Ab line is a straight line, and we have assigned a ab line at 0 level. So this is basically segregating the data in a green bars and red bars. So let's try to learn how to create this type of bar charts. And most interesting part of this plot is that in this plot we have to use if else statement. So we have created this plot with the simple if else statement. So here you can also learn how to use the if else statement in a plotting. So this is our profit and loss vector, and this is a numerical vector because there are only numbers, and these are the bar names. And you can now understand this is basically a character vector because there are double quotes or single quotes, and inside that quotes there are the characters. So it is a character vector. And now move ahead to create this bar plot. So bar plot of profit and loss, and now I am assigning a limit. Ylim is equal to C, and now I am assigning a minimum number. My minimum number is -10 and -25. So I will write here -30 is my limit. -30 is my negative limit of axis, and the maximum number is a 65. So I will assign it here a 70. So in this way, I have limited the y-axis numbers, and then give names.arg, which will create a bar names. And now move ahead to the coloring. And what I have told you, in the coloring we are using if else statement. So write down if else of profit loss. And now what I am doing, see very carefully, if profit or loss is greater than 0, then make it green, otherwise make it red. So I am using to coloring these bars with the help of a if else statement. What I have written, if the profit and loss is greater than 0, make the green bars. If the profit and loss is less than 0, make it is a red bars. So our our bar plot is almost ready. Only we have to write a y-axis name. So how we write a y-axis name? It's a ylab. So ylab, I want the name of ylab is a profit and loss, and my plot is almost ready. Now I have to delete this earlier plot, and I will check whether my code is running. And now you can see our plot is ready to use, but there are some missing data. I want my profit and loss figures here at the center, and for loss making companies or bars, my figures will be at the center. And also there is something missing is a ab line at 0. So I will write down here ab line at the height of 0. Ab line at the height of 0. Now you can see here the ab line is attached. Now we have to give a text to this data, text of profit and loss, and give them labels round profit and loss, comma, digits is equal to 2. And now if I hit enter, you can see the profit and loss numbers are now you can see on the bars. But the problem is they are not at the center. To arrange these numbers at the center, write down profit and loss divide by 2, and now you can see while running code, you can see the plot which is ready to use. So in this way, you can create these profit and loss plots, and now you have a sufficient knowledge about a vector. And in next session, we will learn about a matrix, and then we will discuss about a data frame. So till then, practice it and use these vector in your analysis.